Chapter 5 Number Play. Here Anshu is exploring sums of consecutive numbers. Consecutive numbers, that means continuous numbers. If you are taking 1, next number is 2. So 1, 2, 3, etc. consecutive numbers. If you are taking with starting with 4, next number is 5. So we can take 2 consecutive means 4 and 5, 2 consecutive numbers. 3 consecutive, 4, 5, 6. We can start with any number. If you are starting with 20, then the next 2 numbers, 21, 22, etc. Continuous numbers. Here sums of consecutive numbers. 2 consecutive numbers, 3 and 4. Its sum is 7. 4 consecutive numbers, 1, 2, 3, 4. When we are adding, getting that as 10. 3 consecutive numbers, 3, 4, 5, 12. 7 and 8, 2 consecutive numbers, sum is equal to 15. Same sum we will get if we are adding 4, 5, 6, 3 consecutive numbers. Again, from 1 to 5, 5 consecutive numbers, continuous numbers from 1 to 5. Add all these numbers, we will get the same answer. That means we can write these numbers as the sum of consecutive numbers. Here only positive numbers we are using or additionally. Now we can use negative numbers or subtraction also. To get 0, the sum of consecutive numbers, that means I should use negative numbers. Negative numbers also in that case we have to use. Here take 4 consecutive numbers. For example 3, 4, 5, 6. And put addition sign and subtraction sign between the numbers. We can see 3 plus 4 minus 5 plus 6 or minus sign everywhere. So different way we can put addition and subtraction sign. Evaluate each expression and write the result next to it. So first 2 this given already. 3 plus 4 plus 5 plus 6. And next one 3 plus 4 plus 5 minus 6. Same way this direction. 3 plus 4 we can write here 3 plus 4. Then after that is coming minus 5. This subtraction sign. So minus 5 then plus 6. Same thing 3 plus 4 minus 5. After that minus 6 is coming. So 2 expressions till like the same direction. Now next one 3 minus 4. So this we can write as 3 minus 4 then plus 5 and plus 6. Again 3 minus 4 plus 5 and then minus 6. This one is coming 3 minus 4 minus 5. 3 minus 4 minus 5 and then plus 6. Next one 3 minus 4 minus 5 then minus 6. Then when we are adding all this 3 plus 4 plus 5 plus 6 is equal to 18. Here 3 plus 4 plus 5 minus 6 we will get 6. Next one 8. Here when we will get minus 4. Then here 10. Here it will come minus 2. This one will come that is 0. Here minus 12. After that, here the question, do you notice anything interesting? Look at the answers. 18, 6, 8, minus 4, 10, minus 2, 0, minus 12. So we can see all these answers we are getting that is even numbers. And also positive numbers are there, negative numbers are there and 0 also. Total 8 combinations are coming. Here 2, 4, 6, 8. So with 4 numbers, 4 consecutive numbers, we are getting 8 combinations. So we can write what we noticed in sentence. All results are even numbers. Second point, there are 8 possible combinations. Total 8 possible combinations, and the results can be positive, negative or 0. Now take 4 other consecutive numbers. Place addition and subtraction signs as you have done before, like the same. Find out the results of each expression. What do you observe in that? Here we can take 5, 6, 7 and 8, 4 consecutive numbers. Same way we have to draw the figure, starting with 5, then plus 6, plus 7, plus 8. Next one, when it comes 5 plus 6 plus 7 and minus 8. Then here we are putting plus 7 and minus 7. Plus 6 minus 6. So all 8 combinations we will get. 2, 4, 6, 8 combinations. And the same order we can write it here. 5 plus 6 plus 7 plus 8. 5 plus 6 plus 7 minus 8. 5 plus 6 minus 7 plus 8. Then minus 7 minus 8. Here 5 minus 6. Here it's going with a positive sign or addition sign. Here when it comes down with a subtraction sign. 5 minus 6. Then plus 7 and minus 7. Plus 8 and minus 8. The same way 8 combination. Here we are getting the answer 26, 10, 12, minus 4, 14, minus 2, 0 and minus 16. Here also we can see everywhere we are getting even number. So what we notice from this example, we can write sum and differences, addition and subtraction of 4 consecutive numbers will always be an even number. Also we can write same as the previous question, 8 possible combinations, and the results can be positive, negative or 0. So what we notice through these examples, the result is like the same. Sum and difference of 4 consecutive numbers will always be an even number. Altogether 8 combinations we will get, and the result will be positive, negative or 0. In page number 114, when we are adding 2 odd numbers, always we will get even. Even if we are subtracting, adding or subtracting 2 odd numbers, the result will be even. Again, addition or subtraction of 2 even numbers, the result will be even. So the same type of numbers, odd numbers or even numbers. Both the numbers are the same type, then the result will be even. If one is odd and the other one is even, then the result will be odd. Based on that, the next page 115, we can see breaking even in this question. According to this rule, we can answer it. First one, 43 plus 37. Both the numbers are odd, 43 and 37. So odd plus odd even. 7 plus 3, 10. So this number will be even. So without computing them, find out which of the following arithmetic expressions are even. So this one, it is even. Here subtraction of even numbers, that also even. 4 into 3, 12. We are getting the multiplication here. 12 is an even number and 347 is an odd number. In multiplication, odd into odd number. For example, 3 into 7, we are getting 21. Again odd number. Odd into even, take any number and you can check the rule. Odd into even, that will be even. Even into even, that also will be even. Now here 4 into 3, it's an even number. That into odd number, we will get odd into even, that means even. Here even number minus odd. Even minus odd. One is even number, the other one is odd. Always that will be odd. Otherwise also you can check the unit place. 8 minus 7, 1. Here one is odd number, the other one is even. Again sum also the same way. It will come odd. 9 plus 4, 13, 3. Here again multiplication. Two odd numbers. 9 into 3, 27. So odd into odd. Again odd. Here 3 minus 9. Odd minus odd. That will be even. Here 513 cube. Cube means unit place 3. Odd number. Odd number into odd number. That will be again odd. Again one more time. That will be odd. So 3 into 3, 9. 9 into 3, 27. Again that will be odd. So we put tick mark the even numbers. This is the rule that you have to remember, or through examples, small number, we can check the rule, and then without doing any calculation work, we can find out which are the numbers or which are the expressions are even. In here also we have to find even numbers for any integer values for the letter numbers. First one, 2a plus 2b. 2 into any number, that will be an even number. 2 in here also 2b. So 2a and 2b, both the numbers are even. So the result also will be even number. So we can mark that as even number. According to the rule, even plus even, even. Next one, 3g plus 5h. Here two variables g and h. Both the variables can be even, or both can be odd. If both are the same way, even or odd, the result will be even. But G or H, any one of these is odd and the other one is even, then that will become odd. Because one is odd, the other one is even, then the result will be odd. So we can write both the cases. So when we are writing 3g plus 5h, if g and h both are odd or even, both are the same way, odd or even, whatever it is, then the result will be even. But any one of that, if g is odd and h is even, or g is even, h is odd, even and odd, any one G or H is odd and the other one is even, then the result will be odd. So we can write this expression 3g plus 5h is not always even. So no need to tick that one. This is not always, sometimes odd and sometimes even. So not always even. Next one, 4m plus 2n. 4m and 2n, both the numbers are even. So the sum also will be even. And 2u minus 4v, that also both the numbers, that is even. So the result also will be even. Next one here, 13k minus 5k, same variable. So 13 minus 5, which means 8, is equal to 8k. And 8 is an even number. Even number into any number, we will get the result as even. So we can mark that also even. Here 13 minus 5k is equal to 8k. 8 into any number, we will get the product of an even number with a odd or even. We will get the result even. Next, 6m minus 3n. Here 6m is an even number. This is an odd number. So again same as that, this one. Sometimes even, sometimes odd. So no need to put tick mark for that. Here h square plus 2. H square plus 2 also the same way. If we are putting here odd number, then that will be odd, that plus 2, again odd. For example here, x we are putting 3. So 3 square means 9. 9 plus 2, 11. 11, that means odd number. At the same time, x we are putting even, 2. 2 square, 4. 4 plus 2, 6. That is an even number. So not always even. Same way the next one also, b square plus 1. Say, if we are putting odd number for b, 3. 3 square 9. 9 plus 1, that will become even. At the same time, B we are taking as even number. Then 2 square, for example, 2 square 4, 4 plus 1, 5, odd number. So there also we will get odd and even. So not always even. Next one, 4k into 3j. 4 into 3 is a multiplication. So 4 into 3, 12, k into j, kj. Whatever the number here, odd or even, for k and j, we are multiplying that with 12, even number 12. So the result will be even. So we can mark the last one, this is even. So first one, third, fourth, fifth, and the last one. These are the even expressions. Before starting the exercise questions, in this chapter, the base terms, even numbers. Even numbers means multiples of 2. 2, 4, 6, 8, 10, 12, etc. So even number always ending with 2, 4, 6, 8 or 0. How big the number, if that number is ending with or the unit place digit is 0, 2, 4, 6 or 8, then that number we can say as even number. Then odd numbers in between the numbers 1, 3, 5, 7, 9, 11, etc. Here also the odd number always ending with 1, 3, 5, 7 or 9. Next is factor and multiples. 5 divides 20 exactly, or we can write 20 as 4 into 5 is equal to 20. So 4 into 5 is equal to 20, which means 4 and 5 are factors of 20. 4 and 5 are factors of 20. If we are dividing 20 by 4, 20 divided by 4, we will get 5. No remainder. If we are dividing by 5, we will get the quotient as 4. Without remainder, when we are dividing, there is no remainder, then that type of numbers are the factors. In this example, 4 and 5 are factors of 20. If we are writing 2 into 10 is equal to 20, then 2 and 10 are factors of 20. At the same time, this 20 is the multiple of 2 and 10. So that is the term factor and multiple. 20 is a multiple of 4 and 5. Here 5 divides 20 exactly. So 5 is a factor of 20 and 20 is a multiple of 5. Next is consecutive numbers. We already know that the consecutive numbers, which means continuous numbers. 3, 4, 5, 6 or any number, big number, 100, 101, 102, etc. Whatever that continuous numbers are called consecutive numbers. In general, we can write x. X plus 1, x plus 2, x plus 3, etc. Here any value can put for x. That number plus 1. If you are putting 200 for x, here 200, then it will come 201, 202, 203. So it's continuous numbers. This way continuous numbers are called consecutive numbers. Figure it out, page number 122. First question. The sum of 4 consecutive numbers is 34. What are these numbers? We already know consecutive number, which means continuous numbers. So we can take the numbers that is x plus 1, x plus 2 and x plus 3. Be the 4 numbers, continuous 4 numbers, 1, 2, 3, 4 numbers. And here sum of 4 consecutive numbers, which means sum of these numbers, that is x plus, then second number x plus 1, third number x plus 2, then x plus 3. So first number, second number, third number and fourth number, we are taking the sum, and sum is given as 34. So we can put that is equal to 34. Now look at that, how many, this all with addition sign, positive numbers. So just add the number of times that x is repeated, 1, 2, 3, 4 times. So we can write 4x. x plus x 2x, 3x, 4x, and plus the numbers 3 plus 2 5, 5 plus 2 plus 1 6. So 4x plus 6 is equal to 34. Then 4x is equal to 34 minus 6, which is equal to 28. Now we got 4x is equal to 28. Then we know that x is equal to 28 divided by 4 is equal to 7. So the number x, value of x, we got that as 7. Then what will be the numbers? We can put here the number. For x is 7. Then x plus 1, 8. X plus 2, 9. X plus 3, 7 plus 3, 10. Then we can write in sentence, therefore, the 4 consecutive numbers are 7, 8, 9 and 10. Second question, suppose P is the greatest of 5 consecutive numbers. Describe the other 4 numbers in terms of P. P is the greatest number. So the next number that will be P minus 1. Again, when we are putting one more, P minus 1, that means P minus 2, P minus 3, P minus 4. These are the rest of the numbers. So we can write P is the greatest means P is the highest, greater than P minus 1, and that is greater than P minus 2, which is greater than P minus 3, and that is greater than P minus 4. So describe the other 4 numbers in terms of P. These are the other 4 numbers. You can write in the greater form. P is the great from the biggest to smaller, bigger to smaller. Third question, for each statement below, determine whether it is always true, sometimes true, or never true. Explain your answer. Mention examples and non-examples as appropriate. Justify your claim using algebra. First one, the sum of 2 even numbers is a multiple of 3. Sum of 2 even numbers. So we know that is sometimes it will becomes that is true. So through examples we have to prove that. For that, first we can take, question is the sum of 2 even numbers. So take any 2 even numbers. 2 plus 4, we are getting is equal to 6. And that will be a multiple of 3. Yes, here it is a multiple of 3. If we are taking another number, 2 plus 6. 2 plus 6, what we are getting? 8. It is not a multiple of 3. Sum of 2 even numbers. 2 plus 6, 8. That is not a multiple of 3. This is a multiple. So we can write there, sometimes it is true. Now next one. If a number is not divisible by 18, then it is also not divisible by 9. If it is divisible by 18, not divisible by 18, then it is not divisible by 9 also. That also sometimes. You can write sometimes true. Take example for that. For example, if we are taking 27, 27 is not divisible by 18, but that is divisible by 9. Not by 18, but it is divisible by 9. But divisible by 9. So we can write that statement sometimes true. Third one, if 2 numbers are not divisible by 6, then their sum is not divisible by 6. That is never true. We can write for example, 2 numbers are not divisible by 6. We can take 10 and 8. Both the numbers not divisible by 6. And their sum, 10 plus 8, we are getting 18. That is divisible by 6. is divisible by 6. So this statement is not true. If the numbers are not divisible by 6, here they are saying then their sum also not divisible by 6. But we know that when we are adding, we will get the sum sometimes that is divisible by 6. So this statement is not true. Next one, fourth one. The sum of a multiple of 6 and a multiple of 9 is a multiple of 3. That always true. Multiple of 6 and multiple of 9. So multiple of 6 means any number. If we are taking as for example 6x and multiple of 9. That also any other number variable or the same variable, whatever. So that we are multiplying with 6 and 9. 6 and 9 is a multiple of 3. We can divide 6 by 3, 9 also by 3. So when we are taking 6 and 9, 3 is a common factor. So the result also will be a multiple of 3 or divisible by 3. Multiple of 3. So we can write that is always true. Fifth one, the sum of a multiple of 6 and multiple of 3 is a multiple of 9. That sometimes true. We can write that as sum of a multiple of 6. 6 is a multiple of 6. Multiple of 3, 12 is a multiple of 3. When we are adding, we are getting that as 18. That is a multiple of 9. This is correct. But if we are taking 6 and 9, here also 6 is a multiple of 6 and multiple of 3. 9 is a multiple of 3. When we are adding 15, that is not a multiple of 9. Not a multiple of 9. So sometimes true. Fourth question, find a few numbers that leave a remainder of 2 when divided by 3. We know that division rule, a number is equal to quotient into dividend plus remainder. So here remainder is 2 when divided by k. That means divided by 3. Quotient we can take that as k and divided by 3 plus remainder 2. So we can write the number that as 3k plus 2. 3k plus 2 as the expression. Now when we are putting k is equal to 1. If k is equal to 1, then it will come 3 into 1 plus 2, which is equal to 3. 3 plus 2, 5. If k is equal to 2, then it will come 3 into 2 plus 2. 7. Then 8. 8. Then k is equal to 3, it will come 3 into 3 plus 2. 11. Now we can see the numbers 5, 8, 11, etc. are the numbers. When we are dividing by 3, we will get the remainder 2. If we are dividing 5 by 3, we will get the remainder 2. 8 also. If we are dividing by 3, 2 times, then 6, remainder 2. 11 by 3. 3 3s are 9, remainder 2. So this is the way we can find the numbers. And first we had to frame the expression and then put the values for that variable k, quotient. According to that, we will get different numbers. Now the second part of that question, a remainder of 2 when divided by 4. So dividing by 4, quotient we have to take that as k, and here quotient is 4 and dividend is k. So 4k plus 2. Quotient here we can take as k. Dividend is 4. So 4 into k. Same rule. Quotient into dividend. Dividend means the number which is dividing. So 4 is the number here we are dividing. Quotient we can take that as k. And remainder is coming 2. So the expression it will come 4k plus 2. Before it was 3k plus 2. Because dividend that was 3. Here dividend is 4. Remainder is same. Here also the same way we have to put the value for k. K is equal to 1. Then we will get 4 into 1 plus 2, 6. K is equal to 2, 10. K is equal to 3. 4 into 3, 12 plus 2, 14. So we can write in general 6, 10, 14, etc. are the numbers that leave a remainder 2 and remainder 2 when we are dividing the number by 4. Fifth question is a puzzle. I hold some pebbles, not too many. When I group them in threes, one stays with me. That means that number, if we are dividing by 3, 1 will be the remainder. Then pairing them up. If you are pairing means 2. So if you are dividing by 2, then also odd pebble remains in my view. That means there also 1 it will come. Then group by 5, then again 1 will be the remainder. 1 still around. But grouping by 7, perfection is found. That means completely we can divide. More than 100 would be far too bold. That means less than 100. The number you have to find out which is not more than 100. Less than 100. Can you tell me the number of pebbles I hold? Now here we can see they are dividing by 3, then by 2 and by 5. So take these numbers and find the LCM of these numbers. 2, 3, 5. So 2 into 3, 6, 6 into 5, 30. Whenever they are dividing or making the group of 2, 1 is remaining. The group of 3, there also 1 is remaining. Group of 5, there also 1 is remaining. So the number that will be, LCM is 30. 30, whatever the number, that plus 1. Now 30 plus 1, and again the condition, the number is perfectly divisible by 7. So 30 plus 1 means 31. It is not divisible by 7. Not divisible by 7. Now take the next multiple of 30. 30 into 2. 30 into 2, that gives 60. 60 plus 1 means 61. That also not divisible by 7. Then next multiple, 30 into 3. That means 90. 90 plus 1, it will become 91. Look at that 91, we can completely divide by 7. Here 1 times 7, 2 is the remainder, 21, 3 times. So it will become completely divisible. So 91 is divisible, completely divisible. Divisible by 7. So according to the question, 91 is the number of pebbles. Which means if we are dividing 91 by 2, this is an odd number, 1 will be the remainder. 91 divided by 3. And we are dividing here 90, 30 times, and then 1 it will become the remainder. Again divide by 5. 90, after that 1 will be the remainder. At the same time, when we are dividing by 7, it's completely divisible. So according to that puzzle, the answer is 21. So we can write, therefore, the number of pebbles is equal to 91. Question number 6. The heart has written several numbers that leave a remainder 2 when divided by 6. So we can write the expression as when we are dividing by 6, which means 6k. 6k and remainder is 2. 6k plus 2. And he claims if you add any 3 such numbers, so we can find different numbers by putting k is equal to 1, then k is equal to 2, 3, 4, etc. Like that way, after getting many numbers, then add any 3 such numbers. The sum will always be a multiple of 6. Is that claim true? Is that statement is true or not? First we have to write the expression 6k plus 2 is equal to 6k plus 2, and then put the value for k. K is equal to 1, then it will come 6 into 1 plus 2, 8. K is equal to 2, which means 6 into 2 plus 2 is equal to 14. K is equal to 3, we will get 20. K is equal to 4, we will get 26, etc. Now take any 3 numbers, sum of 3 numbers. First we are taking these 3. 8 plus 14 plus 20 is equal to 42. That means 42 is a multiple of 6. Then take the next 3 numbers. 14 plus 20 plus 26. We are getting the sum as 60. That also a multiple of 6. So if we are continuing any 3 numbers, sum that will be multiple of 6. So we can write yes, Takagat's claim that is true. Question number 7. When divided by 7, the number 661 leaves remainder 3. And the number 4779 leaves a remainder 5. Without calculating, can you say what the remainder of the following expressions will leave when divided by 7? Show the solutions of addition and subtraction of both the numbers. So first we can write the number 4779. That when we are dividing by 7, the remainder is 5. If you want, you can check division. Divide by 7, we will get that as 682 as the quotient and 5 is the remainder. This no need to do, but just I showed that calculation work here to make it more clear. And here 661, that we will get 94. So without calculating, so we know that these numbers is divisible by 7. 682 into 7, 94 into 7, whatever that is divisible by 7. And these are the remainders. So when we are adding the numbers, these two numbers, we will get sum of these two, that into 7. That no need to take it because that already we know that is a multiple of 7, which means that number we can completely divide by 7. Now look at the remainder. Here the remainder is coming 5 plus 3. That means 8. When we are dividing 8 by 7, we will get the remainder as 1. So the remainder will be 1. Here we are doing the subtraction. Remainder is 5, 5 minus 3. So it will come 5 minus 3, that is equal to 2. So in this case, remainder is equal to 2. When we are doing the addition, remainder is equal to 1. And when we are doing the subtraction of these two numbers, remainder is equal to 2. Just look at the remainder, this part. 5 plus 3, 8. That number divided by 7, which means 1 will be 8 when you are dividing with 7. 1 times 7 and the 1, this is the remainder. Here also the same way, 5 minus 3, which is less than 7. So just put that number as the remainder. 8th question. Find a number that leaves a remainder 2 when divided by 3. Remainder 3 when we are dividing by 4. Remainder 4 when dividing by 5. Now we can see a pattern in this. When we are dividing by 3, remainder is 2. 3 minus 2, 1. Divided by 4, remainder is 3. 4 minus 3, 1. Same way here, 5 minus 4, 1. So everywhere the difference between these two numbers, that is 1. What is the smallest such number? Can you give a simple explanation of why it is the smallest? So the question we can write this way. When we are dividing a number by 3, leaves the remainder 2. So dividend minus remainder, that is 1. 3 minus 2 is equal to 1, which means 1 less for the full group. When we are, second case, when we are dividing by 4, remainder is 3. So 4 minus 3, there also 1, which means 1 less than for the full group. Third case, dividing by 5, remainder is 4. 5 minus 4, there also 1 less for the full group. Now first we divided by 3, then 4, and after that by 5. So take the LCM of 3, 4, 5, all the dividends. In all these cases, every case 1 is less for the group. So we are going to find the LCM of this dividend 3, 4, 5. So LCM of 3, 4, 5, that is coming 60. And everywhere 1 is less. So 60 minus 1, 59. Which means 59 is the smallest number. When we are dividing by 3, remainder we will get 2. Dividing by 4, we will get the remainder as 3. Dividing by 5, we will get the remainder as 4. You can check the number 59 by dividing with 3. We will get remainder 2. If you are dividing by 4, remainder 3, and dividing by 5, remainder 4. So 59 is the number, the smallest number.